Good morning, everyone. Today in this lecture, I am going to discuss the various IEEE standards for local area networks. So, there are so many standards such as Project 802, Ethernet, Token Ring, FDDI. We will see it one by one. So, first of all, LAN, local area network. A LAN consists of shared transmission medium and a set of hardware and software for interfacing devices to the medium and regulating the ordering access to the medium. So these are used to share resources, and resources may be hardware or software, and for exchanging the information. So LAN protocols function at the lowest two layers of the OSI reference model, the physical and the data link layer. We can say that IEEE 802 LAN is a shared medium peer-to-peer communication network that broadcasts information for all stations to receive. And what LAN does? A LAN enables stations to communicate directly using a common physical medium on a point-to-point basis without any intermediate switching node being required. So there is always need for an access sublayer in order to arbitrate the access to the shared medium. So these type of networks is generally owned, used and operated by single organizations, and this is in contrast to the wide area networks which interconnect communication facilities in different parts of countries and are used as a public utility. So these LANs are also different from networks such as the backplane buses, and that are optimized for the interconnection of devices on a desktop or components within a single piece of equipment. So there are some features of LAN. I am going to tell you one by one. First one is limited geographical area. So this is usually less than 10 kilometers and more than 1 meter. Okay. And the second characteristic is high speed for the LANs. The speed of the data transfer can vary from 10 Mbps to 1000 Mbps to 1 Gbps and more. So reliability is very high in the local area networks. Transmission media can be guided and unguided. Mainly guided media is used except in a situation where infrared is used to make a wireless LAN in a room. So it depends on the situation which type of media is used. Topology, it refers to the way in which the nodes are connected in a network. There are various topologies used in the local area networks. Next is medium access control techniques. Some access control mechanism is needed to decide which station will use the shared medium at particular point in time. Because if there is a shared medium, every device will want to access that medium. But the problem is which device will use the channel first. So for that there are many procedures to follow for accessing the channel. Okay. So we are talking about the IEEE standards. So what is IEEE? IEEE is the Institute of Electrical and Electronic Engineers. Is an American professional organization. What it does? It defines the standards related to the networking and other areas. So IEEE 802.x standards, and the X has different values, are perhaps the best known IEEE standard in the area of networking. In the area of networking, IEEE 802. Something standards are best standards. So these are a series of standards recommendations, and informational documents related to the network and communications. So these IEEE recommendations distinguish two sublayers in the OSI model: data link layer, a lower MAC is medium access control sublayer, and the upper logical link control sublayer. Here it is shown in this diagram how project 802 can be simulated, can be compared with the ISO-SI model. Here the layer 2 data link layer is divided into two sub-layers, LLC and MAC. What is LLC? LLC is the logical link control sublayer, and what is MAC? Media access control sublayer. So there are several standards starting from 802.1 to 802.11, and these are adopted and superseded by newer versions. The newer versions are 8802.1 to 8802.11 from the ISO, and these standards are accepted internationally. Okay. So there are so many standards. 802.2, 802.1. So what IEEE 802.1 does? It specifies standards for network management at the hardware level. It includes the spanning tree algorithm. Spanning tree we have learned in the subject data structures. So what these algorithms do? This algorithm is used to ensure that only a single path is selected when using bridges or routers or network connecting devices to pass messages between networks, and to find the replacement path if the selected path breaks down. So for finding replacement path, we use spanning tree algorithm, and this standard IEEE 802.1 is used for the network management. At which level? At the hardware level. Okay. Now the IEEE 802.2, it defines the operation of the logical link control sublayer of the OSI models, data link layer, because this is the part of data link layer, LLC. So what LLC does? LLC provides an interface between media access methods and the network layer. So functions provided by this layer LLC, which are to be transparent to the upper layers, it includes framing, addressing, and the error control techniques. And this sublayer is used by the 802.3, that is Ethernet specification. Okay. Now IEEE 802.3. IEEE 802.3 describes the physical layer and the MAC sublayer, and why it is used for the baseband networks. And that baseband network uses a bus topology and CSMA-CD as their scheme for accessing the network. Okay. Now IEEE 802.4. IEEE 802.4 describes the physical layer and the MAC sublayer for baseband or for broadband networks, and that uses a bus topology, token passing technique to access the network, and it can use fiber optic cable also. Next is IEEE 802.5. It describes the physical layer and the MAC sublayer for networks that use a ring topology and token passing to access the network. Okay. Next is IEEE 802.6. It defines standards for the metropolitan area networks whose nodes are scattered over distances of more than 5 kilometers or 3 miles. So these are the IEEE standards. So I am summarizing this LAN standard description. IEEE 802.3 is used for the Ethernet LANs, that is baseband. IEEE 802.4, that is token passing bus local area networks. IEEE 802.5, that is token passing ring local area networks. IEEE 802.6, that is used for the metropolitan area network. IEEE 802.7, that is used for the broadband net LANs. IEEE 802.9, that is used for the integrated services local area networks. IEEE 802.10, that is mainly used for the security purpose. And again IEEE 802.11b, that is used for the wireless LANs dedicatedly. And IEEE 802.12 for any local area networks. IEEE 802.14, that is used for the television, data, voice and internet access. IEEE 802.15, that is used for the wireless personal area network. IEEE 802.16, broadband wireless metropolitan area networks. And lastly is IEEE 802.20, that is mobile broadband wireless access. So these are the standards. Here in this diagram it is shown that the project 802, there are physical layer and physical layer there are 802.3, 802.4, 802.5, CSMS CD, CSM token bus, token ring are used. And if we talk about the data link layer, there are two sub layers, but here it is shown logical link control, and it is also known as 802.2 standard. For the network layer, there is 802.1 internetworking, and there are other layers. And this is the PDU format. There are some fields: DSAP, SSAP, control field and information field. So what is this DSAP? Destination Service Access Point. Destination Service Access Point. And SSAP is the Source Service Access Point. So when data transferred from one point to another point, there are the fields which will be used in with the data format. So upper level addressing, and there are some light blue colored boxes. So there is a DSAP and SSAP fields, and these are used by the IEEE standards. In DSAP, 0 is used for the individual, and bit 1 is used for the group message. And in SSAP, 0 is used for the command and 1 is used for the response. In this way, here it is shown in the PDU control fields. Now 802.3 standard of the IEEE. 802.3 standard is, one is baseband signal and another is broadband analog. So if we talk about this baseband signal, there are different type of cables: 10/5, 10/2, 10/3, 1/5. In the later slides we will see in the detail these cable standards, 100/T. But in case of broadband, there is 10 broad 36. Okay. This is the evolution of CSMA CD. There is multiple access protocol, and after that carrier sense multiple access. After that carrier sense multiple access collision detection. What is this CSMA CD? I have already told you that there are two types of communication medium, transmission medium. One is guided media and another is unguided medium, wireless medium. So if during the data transmission phase, if collision happens, if there occurs collision, at any point of time. So in which type of medium is there is one question, in which type of medium it will be easy to find the collision. So the correct answer is in the guided media, because in guided media path is fixed. The data will travel through this direction, through this channel. We will not talk about the direction. Path is fixed. So on that specific path we have to check whether the collision has detected, where the collision has occurred, and that will be detected. But in case of wireless medium, path is not fixed, and in that case path is open space. So we will not be able to identify the, it is not comparatively easy in comparison to guided media. So what is multiple access? Multiple access means if there is some shared medium and more than one devices are accessing that channel, at a time which device will use that channel. So for that there is a mechanism used in the network, carrier sense multiple access. What is the concept of carrier sense multiple access? If any station, any machine on the network wants to transfer the data, before transmitting the data it will listen the channel. Listening the channel means identifying that whether is there any transmission is already in progress. If there is, if channel is busy, it will again wait, and after waiting some random amount of time it will again sense the channel. Whenever the channel will be idle, it will transfer its data. But if there may be many situations, if there are more than one devices are sensing the channel and both finds the channel is idle, both will transfer the data and the data will collide. So there will be situation of the collision. So which feature will enable us for finding the detection? So there is some protocol. One protocol is carrier sense multiple access with collision detection. So this protocol has the feature of the collision detection techniques. It will help to find the location of the collision. But if we talk about the wireless medium, we will use another technique, CSMA-CA. CSMA-CA means collision avoidance. So there is difficulty for finding the collision where it has occurred. So we will avoid the collision with the help of CSMA-CA. Okay. So this is MAC frame, medium access control frame, that will be sent. So there are so many fields. There are preamble field. It takes 7 bytes. After that SFD, that takes 1 byte. There is destination address and the source address. 6 bytes each. Length of PDU will be 2 bytes. After that there is data. In data there are 4 fields. We have already seen in the previous slides: SSAP, DSAP, control information, and the information about the data. And after that there is CRC, cyclic redundancy check, and it takes a space of 4 bytes. And why it is used? For the error detection, whether the error has occurred or not during the transmission. So there is preamble SFD, where 56 bits of the alternating ones and zeros is used. Start field delimiter flag is used. So here it is shown in this diagram how the data is transmitted and what are the other fields of the required. So this is the Ethernet segments. What is Ethernet first of all? So Ethernet has been relatively inexpensive, reasonably fast and very popular LAN technology. Okay. So the original Ethernet was developed as an experimental coaxial cable network. In which year? In the 1970s by the company Xerox Corporation for operating at the data rate of 3 megabits per second, and for that it used CSMA-CD protocol, which we have discussed in the previous slide, for the local area networks with sporadic traffic requirements. Okay. Okay, so Ethernet properties. Ethernet properties, the topology which is used in the Ethernet properties is bus topology or star topology. So if we use the bus topology, it is known as Ethernet 1.0 or 2.0. But in case of star topology, it is 802.2 based Ethernet. Which access method it uses? Ethernet uses CSMA-CD access method, and the speed will be up to 10 megabits per second. Which type of cable is used in the Ethernet? Coaxial cable, 50 ohms impedance. And another category is coaxial cable 50 ohm standard unshielded twisted pair cable. Fiber optic cable can also be used. Frame size will be 46 to 1500 data bytes, and there are many variants of the Ethernet: 10 base 5, 10 base 5 thick Ethernet, 10 base T twisted pair Ethernet, 10 base F fiber optic Ethernet, 10 base 30, 10 broad 36. Okay, so these are the various variants of the Ethernet properties and Ethernet standards. Now, so this is the arrangement, how the segments are connected and how it uses the repeaters between the devices. So this is 10 base 5. What is this? This is one type of cabling is supported by the Ethernet standard. What does this mean? This 10 base 5, 10 means the data rate will be 10 megabits per second, and the signal will be baseband signal, and the distance will be 500 meters. How many maximum nodes will be supported by each segment? Because their segments can be used, so 100 nodes can be used per segment in 10 base 5 Ethernet standard. What is the advantage? This standard is good for backbones of the network. Which cable is used in this? Thick coaxial cable. Thick coaxial cable is used. Now this is 10 base 5 explanation. There is NIC, there is attachment unit interface, transceiver cable, and the maximum length of transceiver cable will be 50 meters. This is thick coaxial cable. Maximum length of this cable can be 500 meters. These are the, at the end, these are the cable terminators, and there are medium attachment units, MAU transceivers. Why it is known as transceiver? Means it has the capability for transmitting and receiving also. It has both the capabilities. This is the transceiver. There is coaxial cable, there is transceiver and tap. There is one connector is used, that is DB15 connector. 50 meter maximum AUY 15 wire cable can be used. Another category is 10 base 2. 10 base 2 cable is known as thin coaxial cable. 10 base 5 was thick coaxial cable and 10 base 2 is thin coaxial cable. The data rate is 10 megabits per second. Maximum segment will be 200 meters and the maximum number of nodes which can be used per segment is 30. And what is the advantage of this type of standard is this is the cheapest system. Okay, and this is the structure of the 10 base 2 cable, how it is connected. There is cable terminal, there is NIC card, network interface card inside the computers, inside the stations, and there are connectors which can be used, is known as BNC T connector, and it uses thin coaxial cable. The maximum capacity is 200 meters. It can be 185 meters also. Another category is 10 base T. 10 base T. Here T means twisted pair. Base is baseband signal, and the data rate can be 10 megabits per second. So in 10 base T, the maximum segments can be 100 meters, but the maximum nodes per second is increased in 10 base T. Near about 1024 nodes per second, per segment can be used. And advantage is maintenance is very easy in 10 base T. Okay, so this is 10 base T. How 10 base T hub can be used? There are so many ports, and there are registered jack 45 is used, and in that jack through cable NIC is connected in different ports. So this is the hub. There is 4 pair UTP is also used. Now 1 base 5. In 1 base 5, the capacity of the data rate can be 1 megabits per second, and the maximum capacity of the cable will be 500 meters, and this is also the baseband signal. This is 1 base 5 arrangement. There is hub shown in the yellow color, and after that fast Ethernet. What is fast Ethernet and how it works? So in fast Ethernet there are 2 categories, 100 base T4 and 100 base X. In fast Ethernet, the data rate can be maximum 100 megabits per second. Okay, what will be the data rate? 100 megabits per second. There is 100 base X also, 100 base F also. F means fiber optic cable. T is used for the twisted pair cables. So in 100 base T4, 4 pairs of unshielded twisted pair cable is used. In 100 base FX, 2 optical fibers is used. In 100 base TX, 2 pairs of unshielded twisted pair cable, or in spite of this, 2 pairs of shielded twisted pair cable can be used. So in this way, we can understand the concept of fast Ethernet. Okay. So if we talk about the Ethernet, what is Ethernet? Ethernet is a local area network cabling and signaling specification for which type of networks? Baseband networks. And Ethernet uses a bus or star topology for connecting different nodes in a network. If we talk about if we ask a question, which OSI layer does Ethernet belong? So we will reply, Ethernet belongs to both the physical layer and the data link layer in the OSI architecture. What are the standard data rates for the Ethernet? Yes, the data rates for the Ethernet are 10 Mbps, 100 Mbps and the 1 gigabits per second. Okay. There are some collision situation and how that collision is recovered with the CSMS CD. I have already told you. What is broadcast address? In the Ethernet address, in which all the bits are 1, is known as broadcast address. It is represented, we want to represent it in the hexadecimal notation, FF colon FF colon FF colon FF colon FF colon FF. A frame with this address is received and processed by all the nodes in the network, because in broadcast data is transferred from one to all. Okay, thank you.